Welcome to Chapter 6, one of the most critical chapters in the entire course, developing a project schedule. So what we've talked about in the first 5, and in the previous chapter we talked specifically about cost. This is about time. So here's where we are on our network diagram or path to our goal. So we're going to try and understand the linkages between the work breakdown structure and the network project. Anybody who knows anything about project management knows what a WBS is. We're going to diagram using activity on node methods. There's various ones. Don't focus too much on that because there's software programs that do that for you. And you can easily, once you input the information, you can very quickly just click on literally different views like you can in Word, right? We're going to calculate early, late, and slack times. We're going to identify the critical path. We're going to talk a little bit about free slack versus total slack. Total slack is more important. And we're going to talk a little bit about lagging. So really the first 4 objectives are the most important. So again, here's the outline. The network is simply a flowchart of and shows the sequences. You may have seen one of these. All of the schools will have what they call a scope and sequence document that the academic advisors will have. So what the scope is the different types of courses: econ, accounting, marketing, supply chain, whatever. Then the sequence is you take accounting 1, then you take accounting 2, then you take the next level of accounting. You do them in a certain order. And so you take stats 1, and then you take stats 2. You can't take them at the same time, and you can't take the stats 2 before you've taken stats 1. And do you need to take stats 2? At one time, it was mandatory at certain schools to take a second level of statistics course. And then it became an option. So we're going to look at scheduling, and then we're going to also tie it in with the cash flows. When do you need to spend the money? So here's what we're talking about. We have a network diagram, and we have various activities. So you can see specifications, documentations, the protos 1, the final proto, the prototypes, the testing, the software, and then the final version. So this is a very rudimentary way of just looking at it. Oh, and you can see that by the network diagram that the B and C can be done at the same time, concurrently. So you can do proto 1 and preliminary software at the same time. But you can't do D until both B and C are done. That's how you read the chart. And it's much easier to read. And on the left side of the screen, it's like it doesn't give you the sequence. It just tells you the tasks. That's the work breakdown structure, by the way. So activity is the element. An element, it can't be broken down any further. Be careful not to get into too much detail. A parallel means it can occur at the same time. So a parallel activity would be you could be taking project management, and you could be taking statistics, and you could take intro to supply chain or whatever other courses you're taking right now. You could be taking a communications course, depending on what program you're in. A burst is where one activity, it bursts. There's several things that flow from it. So you can, that's why they call it a burst activity. A merge means that 2 activities merge into one, like we just saw B and C merged into D. The path, you would have the various paths that we'll go through. And then the critical path is the longest path. Again, don't worry about the activity on node or the activity on arrow. The softwares will do that. You read from left to right. You can't have all of the activities must be done prior to, so for D, when I mentioned B and C must be completely done before you can do D. That's what it really means. Each activity should be unique. In other words, you have B and C, not B and B. It's like, well, what does that mean? It's like they're just a unique identifier. You can't go backwards. All right, you can't go from accounting 1 to accounting 2 to accounting 3, and then, oh, you can take the course over again. Imagine how many fourth-year accounting students could take intro accounting, make no effort, and get an A or an A+. So that's why it specifically says you can't take a course again for credit. Otherwise, you could go to university, take one course over 40 times, get your 120 credits, and I got a university degree. No, that's not allowed. So here's just some examples. The sequence is ABC. On the second one down, it's a burst because X splits off into Y and Z. J, K, and L in part C is a merge. And then in this particular case, in D, X splits into Z and AA, and Y splits into Z and AA. So Z cannot start until X and Y are completed, and AA cannot start until X and Y are completed. But Z has got nothing to do with AA. So here is the immediate predecessors on the far right. The activities are the elements. Be careful, don't go into too many levels of detail. I had a group one time who had 25 pages of detail and they weren't done yet. That's too much detail. And I'll show you what I mean in a moment. There's be a graphic coming up that what's, so how do you read this? A, you can start now because there's no, like courses you took in term 1, what did you need? Admission to the school. Assigning the team. You can't assign the team until you define the requirements. I mean, how do you know what type of people that you have if you don't know what you're doing? Designing the hardware is done after A, and you read the list as we go through it. So you can see A bursts to be B and C. And here's the network diagram for all of them. So E, I can start E. Let's say you're the building and testing the hardware in activity E. You can do that after it's been designed. But building and testing the hardware has nothing to do with testing the software. And I know some of you who are more technical than I am, that you say, well, wait a minute, they're integrated. But according to this, you can test the software without building and testing the hardware. You have earliest start, which refers to what's the earliest you can start something. That's exactly what it says. Earliest finish, when's the earliest it can be done? The expected time, how long is this project going to take? You can expect, I've been told, and I've asked students over the last many years, for a 4-year degree, how long is it taking you to actually complete your 4-year degree? When I went to university, it was 4 years, but things have changed. The average university student who starts a 4-year degree, so if you started in the fall of 2020, you can expect on average to graduate in the fall of 2026. That's the average. What's the last possible time you can start an activity without delaying the project? And as you get closer and closer to your graduation date, this becomes important. What's the latest you can finish it? What's the critical path? You must have a critical path. You must have at least one critical path. You can have more than one. And this is why some of you have gone to talk to academic advisors. They're very good at helping you and identifying, they may not term it this way, the critical path. How would you feel if you say, I got 2 courses left to graduate, but I have to take the first one and I can't take them at the same time, then I have to take the second one. So I got 2 courses left, it's December, it's gonna be a year before I can graduate. It's like I should have planned it better. That's why you have academic advisors. And then how long can the activity be delayed without delaying the entire project is called slack, or sometimes called float. So here's the times that you have. So what we're going to do in this particular case, we've got our network diagram. You can see the activity is identified as A, define requirements, and then Yes? Hello? Hi. Oh, you guys are supposed to point it. It's not just like I'll show you. Sure. Come on. All right. It's just in the middle of recording something. So that's fine. It's all good, guys. Okay. So yeah, so you got it on this side here going to their roof. Yeah, I'll show you. All right. All right. You can see them. Yeah, I should look at that. Yeah, okay. Because ironically enough, on the other corner there's a lost mess. Oh, sorry. You're slow. Okay. Yeah. So if you need to move stuff, sure, we'll try to move that. So I'm gonna use this. Okay. Whatever works for you guys. Yeah. You guys do it whatever way is safe for you guys. Sure. Whatever works. If you need to move some of my furniture out of the way, that's fine. I am gonna close this. Yes. Close the door as well so that no dust drips in or no rain drips in. Okay. But you will want to avoid the balcony for the rest of the day. That's fine. Should be done by tomorrow morning. It should be good. Okay. Good. No, so you guys want to? Yeah, just it's not windy or anything. Yeah, no, that's fine. Whatever works for you. Feel free to move the table. You need to move this. I mean, that's actually not that heavy. So I'll close this. All right. Hello, sorry about that. I got interrupted unexpectedly. So I'm going to continue. Sorry for the pause. So A is to find the requirements. Takes 10 time units. I believe they're in days, but it doesn't really matter. There's a little legend in the bottom right-hand corner. Earliest start, earliest finish, slack, latest start, latest finish. When you move forward, which is called the forward pass, you add, and you go from left to right. So activity A starts at time 0, goes to 10. Then that 10 goes into B and C. They've done a very nice job of identifying the where the numbers come from or where they go to. Then in B, you take the 10, you add the 5, and you get 15. For C, you got 10 plus 25 for 35. And you continue to the right. You can see in this case that H is the final activity, and it's 85 is the earliest it can start. And it takes 15 days to complete, which means it'll be done day 100. So this project takes 100 days to complete to do the automated warehouse order pickup system. So you take the earliest start, add the duration, you get the earliest finish. And as I said, the earliest finish is the absolute earliest. What's the fastest you can do it if everything goes exactly according to your plans? So in this particular case, you do what's called the backward pass. You take the 100, you subtract the 15 to get the 85. The 85 goes into the bottom right-hand corner for G and the bottom right-hand corner for F. So for G, you take the 85 minus the 35, gets 50. Then that 50 goes to D. 50 minus 20 is 30, and you just subtract. So so you do that for all of it. Now, if you have a situation where you have multiple activities, so for example, when we're moving backwards, if you look at F and E, both go backwards into C. So you see you have the 35 and the 75 in the bottom left-hand corners. You take the smallest number. So when you're moving backwards from E and F back to C, you take the smallest of the LS's. When you're moving forward, and in this case, the only time we have a merging going on is E and G. When you have a merging going on, you have 85 and 85, so it's 85. Oh, sorry, 85 and 70, the top right-hand corner, the EFs. You take the largest number. So to summarize, When you move forward, you add. And if you have two numbers to choose from when there's a merging, you take the largest number. When you move backwards, you subtract. And when there's two numbers to choose from, you pick the smallest number. Now, just to clarify one point, there's actually three, G, E, and F, when you go to H. So I only identified E and G, but there's three of them, G, E, and F. So you can see on the screen, they've got 70, 85, and 50. Because you're moving forward, you pick the 85. All right? Now, the other thing to calculate slack is simply the difference between the top numbers and the bottom numbers. It doesn't matter if you use the left, so you can use ES and LS, or EF and LF. So you go LS minus ES, or LF minus EF, and that will give you the slack. So in that particular case, just focus on total slack. The total slack tells you how long you can delay an activity without delaying the entire project. Now, if you see the number at the top, like the past, the total slack is 15, 15, and 15. That's not 45 days of slack. That's 15 in total. So if B gets delayed by 3 days, you'll have 12 days left for D and G. So the total slack is more important than the free slack for our purposes. And again, the software will calculate this for you. There will be one path that will have no slack. And that path is the critical path. So the critical path is A, C, E, H. How can I tell? Because this total slack is 0. So any delays on the critical path will cause your entire project to be late. And this says what I just said in written form. Don't worry about free slack. It just has to do with an individual activity. So the critical path is the longest path. You need to pay the most amount of attention to it. It's fairly straightforward. You also should be careful if a non-critical path has very little slack, like let's say it's 1 or 2 days, that if there's delays there, then it can become the longest path. So pay attention to the critical path, but also pay attention to near critical paths. So here's some logic errors. We have a loop. It's not allowed. Remember, you can't go backwards. And they just have identified this using, this would be a screenshot from Microsoft Project. Again, this is for Microsoft Project. So this is just some screenshots of what it would look like. And you can, in Microsoft Project, usually the critical path is red. And you can change the color, but you can also see by simply looking at the slack, the design requirements, design the hardware, build and test, and integrate. Those are the things that I have to pay attention to. I got lots of slack in the others. So if somebody wants some time off and they're on the design team, sign team, yes. If they're coding software, yes. If they're testing software, yes. But the others, if you give the person a day off or there's a delay, your project will be late. So again, this is just showing you some of the relationships. Finish to start, which is pretty straightforward. Submit the order, and then you receive the goods. Lagging, again, this is just sort of FYI kind of thing. Concurrent engineering means you have this overlap. What you do is you don't wait, for example, you don't wait for all of the product planning to be done before you start with the systems engineering. So you can speed things up quite a bit. So let's say you get to 80% of the product planning, then the systems engineers can start to look at it. And then the same thing once the system engineers, they don't have to be completely done before the engineering, design, and development. In fact, it's a good idea to do it that way because they can identify certain requirements that are the systems engineers can still build in when it's not set. And then you can do the testing. You can do it again, the finish to finish, which is very rare. Start to finish, even more rare. Combinations. Just again, these are just identifications of different lags, different possibilities. But these three occur less than like 1% of the time in total. All right. So that's our key terms. Sorry for the pause in the middle. I had an unexpected somebody show up at my door. So thank you for your attention. And again, sorry for the delay.